Ever wondered what the universe looks like if you zoom all the way in and then all the way out? Spoiler alert, it's not just stars and galaxies. There are 6 mind-blowing layers that make up reality itself, from quarks to the multiverse. Stick around, because by the end of this video, your definition of big and small will never be the same again. Level 1. Quarks, the tiny titans. If the universe had a smallest piece trophy, quarks would win it hands down. These are the tiniest known building blocks of matter, the Lego bricks that everything else is made from. Discovered in the 1960s by physicists Murray Gell-Mann and George Zweig, quarks are the reason atoms, planets, and people even exist. Without them, there would be no protons, no atoms, and definitely no pizza. Quarks come in 6 types, or as scientists like to call them, flavors: up, down, top, bottom, strange, and charm. Yes, apparently physics got hungry and poetic at the same time. They stick together in groups of 3 to form protons and neutrons, held tight by a mysterious glue called the strong force, the mightiest bond in nature. Everything you see, touch, or tweet about starts with quarks. They've helped scientists unlock the strange world of quantum mechanics. Though studying them isn't easy, they're too tiny to see, and the math is so complex it might as well be alien code. Still, experiments at CERN's Large Hadron Collider give us glimpses into their behavior, paving the way for breakthroughs in quantum computing and futuristic materials that could one day change everything. Level 2. Atoms, the cosmic building blocks. Once quarks team up to form protons and neutrons, they take things to the next level. Atoms. These are the real MVPs of the universe, the structures that make up everything from your morning coffee to the stars in the night sky. The idea of atoms isn't new. The Greek philosopher Democritus imagined them thousands of years ago, but it wasn't until the early 1800s that John Dalton gave us the first scientific atomic theory. And that theory changed everything we know about matter. An atom looks simply but hides incredible complexity. At its center sits the nucleus, a dense core of protons and neutrons, surrounded by electrons zooming around like hyperactive bees. Each element in the universe is defined by how many protons its atoms contain, which is why gold doesn't behave like oxygen, and why breathing air feels very different from wearing jewelry. Atoms are the reason chemistry exists. They bond, break, and rearrange to create the materials of life, from DNA to skyscrapers. But they have their downsides. They're invisible to the naked eye and can turn radioactive under certain conditions, which isn't exactly great for humans. Still, mastering atomic behavior has changed the world. It powers nuclear energy, fuels modern medicine, and drives technology from microchips to MRI machines. In short, atoms are nature's multitaskers, tiny, tireless, and totally unstoppable. Level 3. Planets, the cosmic neighborhoods. When atoms and molecules come together on a massive scale, gravity steps in as the universe's ultimate organizer, sculpting planets out of dust and gas. These cosmic neighborhoods are the homes of weather, landscapes, and in Earth's case, life. Humans have known about planets for thousands of years, but it wasn't until the 17th century, with telescopes in hand, that we realized they weren't wandering stars but entirely different worlds. Each planet is a unique masterpiece. Some are rocky like Earth and Mars, perfect for standing on and complaining about gravity, while others like Jupiter and Saturn are gaseous giants, all fluff and fury. They orbit stars, held in place by the delicate balance between motion and gravity, like cosmic dancers circling a glowing spotlight. Planets give life a stage to perform on. They provide resources, atmospheres, and the potential for biological miracles. Studying them has also unlocked insights into how Earth formed and evolved. But planets aren't always friendly. Most are too hot, too cold, or too deadly for life. And even with our best technology, visiting them is a logistical nightmare that makes a trip to the grocery store look like teleportation. Still, planets are irresistible to scientists and dreamers alike. NASA, ESA, and private companies like SpaceX are exploring them to understand habitability, search for alien life, and maybe, just maybe, find a second home someday. Because if Earth ever sends us an eviction notice, it's nice to know the neighborhood's pretty big. Level 4. Galaxies, the star cities. If planets are neighborhoods, galaxies are full-blown cities, vast, glittering metropolises made of billions of stars, planets, and cosmic clouds all bound together by gravity. For centuries, humans thought the Milky Way was the entire universe. Then, in the 1920s, Edwin Hubble peered through his telescope and shattered that illusion, discovering countless other galaxies beyond our own. That moment expanded not just our understanding of the cosmos, but our sense of awe. Galaxies come in all shapes and personalities. Spirals that twirl gracefully like the Milky Way, smooth ellipticals, and irregular ones that look like they were painted by a drunk cosmic artist. At their centers lurk supermassive black holes, invisible beasts that hold everything together with gravity so powerful it bends light itself. The beauty of galaxies lies in their scale and purpose. They're star factories, constantly birthing new suns while recycling old ones into stardust, the very stuff we're made of. Studying them helps scientists trace how the universe evolved, how stars form, and even how dark matter shapes cosmic structure. But galaxies have their downsides, too. They're unimaginably far away, so the light we see from them is ancient, a snapshot from billions of years ago. And sometimes, they collide in slow-motion cosmic pileups that completely reshape their structure. Still, observing galaxies through telescopes like Hubble and James Webb is like looking back in time, giving us front-row seats to the universe's greatest story, one written in starlight. Level 5. Galaxy Clusters, the Cosmic Web. Just when you think galaxies are huge, the universe laughs and says, "Hold my dark matter." Galaxies don't just float around alone. They gather in gigantic clusters, bound by gravity into vast communities that span millions of light years. These are galaxy clusters, the next level up in the cosmic hierarchy. The idea of them came to light in the early 20th century, when astronomers noticed galaxies tend to hang out in groups rather than isolation. A single cluster can hold hundreds or even thousands of galaxies, swimming in a sea of hot gas and invisible dark matter. They form part of the cosmic web, an enormous network that connects everything in the universe. Picture it like a 3D spiderweb made of galaxies instead of silk, with gravity as the thread that ties it all together. The strength of galaxy clusters lies in what they reveal. By studying their movement and structure, scientists can map out how the universe is expanding and even estimate the amount of dark matter and dark energy out there. They're like the universe's balance sheets, showing where all the mass and energy really go. But of course, they're not easy to study. These clusters are so distant that their light takes billions of years to reach us, and their environments are so extreme that life as we know it couldn't survive there for even a second. Still, they're crucial to cosmology, helping us understand not just where we are, but how everything connects on the grandest scale imaginable. In short, galaxy clusters are the universe's ultimate group project, and for once, everyone's actually pulling their weight. Level 6. The Observable Universe Multiverse. Now we've reached the grand finale, the ultimate zoom out. The observable universe is everything we can see, measure, or detect with our instruments, a cosmic bubble roughly 93 billion light-years across. Inside it lives every galaxy, star, planet, and particle we've ever discovered. But here's the twist. Beyond that boundary, there could be more. Enter the multiverse, a mind-bending theory suggesting our universe might be just one bubble in an infinite cosmic foam of other universes. Yeah, let that sink in. The observable universe gives us a window into cosmic history. Every direction we look, we're seeing the past, ancient light that's traveled billions of years to reach us. It helps scientists understand the Big Bang, dark matter, and the mysterious dark energy that's making the cosmos expand faster and faster. It's like the universe's diary, except we can only read the first few chapters. The idea of a multiverse pushes that imagination to the edge. Some theories suggest each universe could have different physical laws, maybe one where gravity is weaker, or where pineapple pizza actually tastes good. The benefit? It helps explain why our universe seems so perfectly tuned for life. The downside is currently untestable. We can't peek beyond our cosmic horizon. For now, it lives in the realm of theory, philosophy, and really expensive sci-fi movies. Still, the thought of multiple universes gives us a thrilling sense of possibility. Maybe somewhere out there, another version of you is watching this same video but backwards in zero gravity.